absent. Ranjani, you were absent for the last class?
I was also absent, sir.
Raghav, you were also.
House didn't let me in, sir.
Okay, you joined late, but did you attend the class or not?
Late, but in the meeting it showed as the host did not let you in inside the meeting.
Okay. Again, recall everything what I taught in the last class before starting today's class. So let us recall first. So in the previous class, I started effects of electric current. So understand that in the beginning, I am talking about 700 years back, when there was no magnetic effect of electric current. Current itself was not there by the time, and magnetism was only magnet. Do you think it is a special element in the periodic table? No. Do you think that we get it in the earth? Yes, we get it. Asia is the island name, man, where we got it. My question is, which material is magnet? Whether it is iron, whether magnets? He says yes. You say no. Okay, then which iron ores are magnet? Ions. Oh, some universe, or I'm talking about the earth first. In the earth, we have magnets which are naturally occurring also, like one which we got in magnets are iron. Understand that first. But all the irons are not magnet. Right? Now, iron, if the domains inside the iron domain, you will ask me, those things you learn in higher class. Domains are the arrangement of magnetic dipoles. So for you, just domains. So that iron will have magnetic properties. It will be magnet. Okay. So in earth, wherever you are finding iron, there are two possibilities that aligned in the same direction. Not only iron, actually nickel also has magnetic properties. Some elements where the magnetic domains are arranged in unit, or that particular metal will be magnetic in nature. But out of all, a few in which domains are unidirectional, are magnetic, others are non-magnetic. That number of times the magnetic domains once again goes in random direction, once again it becomes non-magnetic. So naturally occurring magnets, you should not drop too much. If you drop it too much, it won't have magnetic because its domains once again go in random direction. So the reason for magnetism inside a bar straight line, that is similar direction. Now in we will study about what is a domain, how it is formed, and why in some other metal it is not in the same direction. These things we have domain theory in 12th. Please ask me. Yes, we can bring it. You know how? If you keep that magnetic substance in magnetic field once again. So when you keep it magnetic field, then those domains starts aligning in the direction of magnetic field. Are you getting? Those domains, because of vibrations, it changes. But if you are able to keep that magnetic substance in a strong magnetic field, yes, the domains will once again align in this. When we heat a magnetic substance, its domains may once again get de-aligned. So these things are not required for you. Just we are not going to learn about magnets. We are going to learn about magnetic field through a wire. It also produces magnetic field. If he took the current carrying conductor in which, for example, straight current carrying conductor, circular current carrying conductor, many loops of current carrying conductor, and why he was doing all this? Because he wanted to get a magnetic field very similar to a bar magnet. Bar magnets are being used, I want to replace it with electromagnets. Again, the reason is to have more magnetic field. If you have a permanent magnet, I cannot change its magnetic field. If it is 5 units, for sure. But if you have an electromagnet, if it is 5 units value, you can make 10 also, you can make 1 also, you can make 0 also. Discovery was made, it was a phenomenal discovery, and it led to lot of applications of magnets. So first what he did, he took a straight current carrying conductor. He took a cardboard, he made a hole in that, passed the wire straight through it, connected with a, and he spread some iron filings on the board. He tapped the board. He saw that, okay, when they arrange themselves in concentric circle, we come to know the magnetic field is having a shape of concentric circles. Later, when he battery, he saw that the circles is still remaining concentric, but it is in opposite direction. Clockwise direction was verified by compass, and direction of magnetic field is given by right hand thumb rule, which says that if you hold a current carrying conductor in your right hand in such a way that your thumb is pointing towards direction of current, then the forefinger of magnetic field. And I told you, don't think that the answer should be always. I said to you, if there is a condition where there is a wire taking the current like this, okay, what will be the answer? Into the plane, because when I keep my right hand on this, fingers are trying to go inside the plane in the A direction, so it will be into the plane. I hope I've said. And I also told you, if B, if you see, it is trying to come out of the plane, isn't it? Many children, for them, right hand rule means answer should be only clockwise or anti. Like this, you should say into the plane or out of the plane. Are you getting about in the last class? Magnetic field due to circular current carrying conductor. Before that, is magnetic field, by the way. Magnetic field is proportional to I, and magnetic field is inversely proportional. It means if there are 2 points, one point is here, another point is here, point A and point B, which point will have strong, which point will have more magnetic? A, obviously A, because magnetic field is inversely proportional to R. The more closer the point is, the more stronger the magnetic field is, and the more far the point. Second thing is, it is proportional to I. If there are 2 wires, in one wire I am having 2 ampere current, another wire I have point P. Here also I go 1 meter away from it, point Q. Which point will have more magnetic field, P or Q? Q, because 5 ampere field due to a circular current carrying conductor. And we saw, if you want to find experimentally, take a cardboard, make 2 holes, pass circular current carrying loop through 2 holes, spread iron filings, tap the board once again, and in concentric circles, and it is becoming straight line in the center, isn't it? So magnetic field will look something like this. If this is a circular current carrying conductor, it looks something like this. Idea. Now I am getting something similar to the bar magnet, and then Oersted circles, and he made a solenoid which had very similar, almost same magnetic. Once again is proportional to current, and magnetic field is inversely proportional to radius. Loops having same current, but one is having radius 1 centimeter, one is having radius 2 centimeter. The previous scenario, am I right? Apart from that, we talked about the solenoid as insulated copper wires wound in cylindrical turns and form in cylindrical shape and pass current through it. Then this magnetic field inside solenoid is uniform, very a soft iron. If I am keeping field of solenoid is increasing, because this soft iron will get added up and you will have a stronger magnetic field. So if the question is asked like, in solenoid, how we find north and south poles? Permanent magnet. what it will become? It will become permanent magnet. But if you keep a soft iron, what it will become? Increase the magnetic field. Question can come like this. Question can come like, how do you increase the magnet? And I said you, magnetic field is proportional to current inside the solenoid. It means if I want to meter 200 turns, same magnetic field. But one unit length. Second is current. Obviously, in all the cases we are seeing this. Current increasing will increase the magnetic field. Generally, again, it's based upon the domain theory. So if you take soft iron, magnetic field only till we provide external magnetic field. Okay. But in this case, when you magnetize, I am magnetizing it permanently. But suppose, as I gave example to you in the last class, we want to make a device. Are you getting? Permeability is the, inside this free asked. He has asked about a direction. Why I am taking out this thing is because I told her side is positive. That side becomes south pole. Are you feeling this? Negative. This will become south. This will become north. There is a rule for it. If you again you will learn in higher class. The rule says that hold these current is going like this. It is going no. So my fingers are pointing. I would have entered in this direction like this. See, entering like this, like this, like this, like this. So my fourth direction of current. Then the thumb will point towards south pole. Next class, come with water in your bag or something. Come fast. Shall I proceed? So next, today's class, before I start, let me take a very simple question from where we left. And the question is like this. The uniform magnetic field. If you draw the whole thing, tell me. Drawing the whole diagram like this. See, somebody is drawing the answer like this. Then will the answer be right? Straight current carrying conductor has concentric circles. If electric magnetic field, how will you represent? By drawing straight lines. The same thing is there in everybody. I'll ask some people. Don't shout the answer. Question is open to everybody. Question is choose the correct option. Okay. Good. What is the answer, Satvika? What do you think? Nikhil, that magnetic field inside solenoid is uniform. Did I say that? If you are there in the class and listening to me. The heading is force on a current magnetic field. Force on current carrying conductor kept in magnetic field. Only attracts, Mr. Sujit. Unlike poles, attract. If you are bringing south towards north, attraction will take magnetic fields. When same happens in this case also. The heading is force on a current carrying having a current carrying conductor which already has a magnetic field in a new magnetic field. These two and one is the magnetic field produced by the current carrying conductor. Now when these north-south pole and then I am having a setup where I am passing a field by a horseshoe magnet, these two magnetic fields will interact and finally then in the same experiment if you change the polarity, if I take the direction as opposite, see now, so a particular wire which was bending like this earlier, now it is bending like this. Are you feeling the diagram? Now right hand rule is not there in your syllabus, I think, but whatever, it's there. So motor generator.
Motor is not there.
I am asking generator, man. Seriously? In my knowledge, it is not there. So if I talk about Fleming's left hand rule, please pay attention. Finger and your thumb each other. Please pay attention. It's very simple. You'll understand it if you're listening to me carefully. First finger, the thumb will represent the direction of force. I'll repeat it. When first finger, middle finger and thumb are mutually perpendicular to each other, the first finger gives direction of magnetic field, middle north to south, so magnetic field north to south, and the current. Previous case, see what was happening? The current was which direction? From down to up, isn't it? From down to up. So magnetic field is like this, but the current is going upward. What is this magnetic field? What is this magnetic field?
Outside.
Outside. Into the plane, man. And in the conductor, current is going towards right. Are you understanding? Now tell me, rod taking the current towards right, kept in the into the plane magnetic field, automatically, if you have a proton moving towards right. To right, the magnetic field is into the plane. In which direction? 3, 2, 2.
Two, sir.
I hope you know that direction of current is in the same direction. By mistake is mistake. You cannot go and click one more question to you. Think and answer to the plane like this. None of these. I'll repeat. Electron enters the magnetic field which is into the plane. What will a curved path, a circular path? None of these. I hope electrons enters the magnetic field which is into the plane magnetic. A circular path or none of these?
Curved
The
path.
circular path, sir.
Circular path.
Sir,
Okay, yeah.
Sir, curved path.
Curved path. Good. The question still. There is a magnetic field like this. Electron is entering.
Electron.
Okay, very good. Electron enters like this. This electron will have a straight path like this. You said none of these, Bharat, right? You said circular path. Are you sticking with your answer? Okay. Okay.
Yes, sir.
Okay. Let us see the answer. Be the direction of current.
left, sir.
Left.
Sir.
So
Left, sir.
current is like this, right? Magnetic field inwards and current is in this direction. Which direction? Will go and go like this, isn't it? Then why you said circle? Is it curved or circular? Curved. So answer is curved? No. I'll tell you. See logic, very good question. Magnetic field is inwards if the electron opposite direction of movement of electron. So which side the force will act? Force will not be able to go straight down. It will once again be pushed towards which side? Left side. Will it be able to go towards left? No. What will happen? See, to the plane, this middle finger towards left or towards right. This it will take a curve and go like this. Will it be able to go straight? Circular path. Answer is correct what you told. Are you getting the reason for that? Because every time it is taking a path, force is pushing it to go upwards. When it is trying to, force is making towards right. So it will take a what path? Circular path. If the question paper is scope of study, but I am teaching you beyond that. If a question paper is very tough, this kind of question can come. Why not? Magnetic field, it's something like that only. Or shall I proceed further? Any doubt is there? No? See, for taking notes, I'll share the video link in the group. You can see and take the notes. I'm teaching today rather than giving more notes to you because I want to finish the syllabus. That's the point today for this topic. Is it clear?
Circle, how it becomes circle.
Well, I'm repeating, pay attention, Aditya. I said that when acts towards left, do you understand, Aditya? Do you accept it? Be unmuted for some time.
Yeah.
So when the electron,
Yes, sir.
yes. So current is left and magnetic field is inwards. What is the direction of force, Aditya? Because direction, opposite direction of movement of the electron. Am I right?
Oh, okay.
Do you know? Please be aware about this.
Okay, understood, sir.
You understood how circular path came?
Yeah.
Okay. Anybody else who has any doubt, or shall I proceed further? Can I proceed? Proton moving, or they may say alpha particle moving. What is alpha particle? Anybody knows? What is 2 plus, which is positively charged particle? Positively charged only, correct. But what is alpha? Alpha means helium. Two possibilities. It can be positron, positively charged, or electron, negatively charged. So beta has 2 parts. Beta can be taken as beta positive. Alpha particle means positively charged particle. So if they say that alpha particle is right hand side direction. Alpha particle moving in upward direction. Which direction will the alpha particle go? Left. Impossible. Which direction? Towards right. And where is the current? Current towards upward. What is the direction of thumb? Into the plane, no man. Go straight, it will start going like this. Alpha, which was trying to go straight like this, will take a circular path only, ultimately. Is in waiting room. Oh, he's in 11th standard. Okay, fine. Are you clear in this? Repeat what, man?
The alpha
Alpha particle is a positively charged direction. So the alpha particle is moving in upward direction, Raksha, and it is going like. And since it is positively charged, the current will also come in the same direction, right? And I said that magnetic field is towards right. Then you use Fleming's left hand rule. It will point towards into the plane. It's going inside the plane. So the answer for this question is the alpha particle going to go straight like this, will take a turn and go inside the plane. I hope you're understanding, Raksha.
Got it.
Okay, okay, okay. Fleming's left hand rule, I told you, you can just copy it later from the video. I'm going to share the link also. Please copy it later, because now I'm going to kept in magnetic field is clear. How the questions will come in the exam, is it clear? Positive charge moving, negative charge moving. Gamma is energy. Gamma is not any particle. Gamma is when an electron is jumping from one level to another level. Okay, thank you. So next is domestic electric circuit, where we are going to study that.
Parallelly.
Okay, I'll talk about that. So what happens when the current comes from where the current comes to your home? Power. The current from the power, like what is the nearest power station we have? Chennai. From where we get the Kishore? Good. Only Kalpakam? Kalpakam cannot produce that much electricity. How much Chennai uses? Chennai is having a bit. It is in Kalpakam, which is nuclear power plant. Neyveli is far, 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 isn't it? It's not in 1 kilometer, 2 kilometer. It is in almost 200 kilometers from here. Am I right? It comes in very high voltage, almost 2 lakh volts, and that once again they will start, and they will bring to. So once again from around 1 lakh volt, it will make to 20,000 volt, or maybe lesser than that. Then once again that comes, from the government side, they give you a live wire. They will give you a live wire with a given potential. 220 minus 0 is 220 volt, isn't it? So there are 3 points. One is live, one is neutral. This fuse, yes, fuse. And nowadays we have this MCBs as fuse, which we are having in our giving to you. How much you are consuming actually, isn't it? How much we want. This meter is for checking how much you have consumed, how much kilowatt hour, whether you have consumed parallel only. Domestic supply parallel. The electric combination, series combination to the main board. Then only it can measure all the current. If it is to where? Meter board. One coming out directly and use it. If you are that much intelligent, how to sophisticatedly make. I'm going to take out open eye, no? I'm going to make some hidden path for that, and I will take it. Then they will not catch. Okay. So don't try this at home. Why we give earth wire? Why do we give earth wire? Whenever there is an overloading, 3 AC you take 3, computer old computer have 2. Yeah, which has metals good, which has metal, which is consuming too much power. They will always have 3. Exactly. When you put it inside, then only your live and neutral will touch. That's why your earth point is always lines. One is called as 5 ampere line, one is 15 ampere line. Olden time we need 15 ampere. If you are using washing machine, it needs 15 ampere. If you are using a high 10,000 watts, then you may need more than 15 ampere also. Otherwise it will burn. If you go to commercial space, and after that whatever you said, that is parallel. Somebody said parallel. Very good. This answer everybody will remember. If one is damaged, nothing will work. So we want series parallel. Bigger appliance, they will consume more like power volt only. Provide all the points at same possibilities of live connection they are giving. Nowadays in at same possibilities of live connection they are giving. Nowadays in home we have three-phase connection. So in all three we have live wires. Only one, but you will have switcher in your home. Only one, but you will have switcher in your home. Red color thing. You can 1, 2, 3 changer we say, isn't it? So suppose in one, or sometimes if you can 1, 2, 3 changer we say, isn't it? So suppose in one, or sometimes if you are using too much appliance in your home, then you need more power, more current. So we go for multiple phases at home. Points, that is because if you go to some appliances, they will use only the distance between them. Some appliance will be bigger, one earth. And if you go to some other country, suppose you are in US, we give different possibilities of connection. Okay. This domestic circuit, which is in parallel connection, I hope you understood why it is parallel. Actually, time is going beyond 7 and other class has to start. So I need another 15-20 minutes to talk about this. Now is short circuiting, overloading, and some past year questions. So I'll do all these, how the questions are being asked in the examination. Furthermore, we will talk a little more about